So stars and bars is just a counting method. It's a counting method that enable us to count in the most fastest way. The sort of like called advanced counting. Beyond the normal counting, we want to count also for problems that are advanced, like for advanced counting. The normal counting, we were applying it, for example, if I go to a class of 30 people and I want to, in how many different ways can I choose 5 people in the class of 30 people? So obviously it should just be 30, choose 5. That's the normal counting we are used to. Then the bars and stars takes us to an advanced counting where we are trying to count, but the problems are now rather advanced now because it's sort of you are working with 2 different groups. For example, if I had a question, how many ways can we choose 3 cookies from 10 cookies? This is just the basic counting that we're used to. How many ways can I choose 3 cookies from a packet that has 10 cookies? Then we just, okay, there's just 10, choose 3 ways. From 10, I'm just gonna choose 3. But with bars and stars, it's quite advanced because now we are not only concerned with how many ways can you choose 3 cookies from 10 cookies, but we are rather saying also how many ways can you give these 3 cookies to maybe a group of 4 students. So you can see it's working with 2 groups. I'm not just gonna select how many ways can I distribute these 3 cookies to a group of 4 students. So you can see it's choosing in a double way or in an advanced way because I need to choose my 3 cookies and then go and choose students here that I'm gonna give. And they are saying it's also allowable that some of them won't get, doesn't matter. So if I have a group of 4 students, in how many ways can I give them 3 cookies? You can see that already one person won't get because you have 3 cookies. So maybe let's make it a more realistic. 5 cookies giving 4 students, how many ways can I do that? Then they said this is quite an advanced counting. Then we have to use the stars and bars in order to be able to count this. Now, because it's really advanced, you have your 4 students, you need to distribute these 4 cookies, and you can see you can't say 5 choose 4. It's wrong because you are working with 2 different groups. You have your groups of cookies, they need to be given to students, and it's also allowable that some of the students might not receive these cookies. So because you have 5, someone will take 2. You can distribute it in many ways because if you have student A, B, C, D, because there are 4 students, you can give this one 2, you give this 1, 1, 1, and you can see you have distributed all your 5 cookies. That's the first way. Someone can say, what if I gave B 2 and give this one 1? That's the another way you can do it. Someone can say, what if I just give them all 1, 1, 1 and keep my 1? So you can see there are really many different combinations that can be made. And for us to be able to count this in the fastest way possible, we use the bars and stars method. So the idea is the stars represent our number of indistinguishable items. Number of indistinguishable items. Don't know the spelling, but indistinguishable items. Yeah, the number of indistinguishable items or the number of similar items. Then the bus, it's those that we are giving to. Obviously, if you are giving to people, people are different by their nature, male, female, and many other things. So the bus is the number of distinguishable items. So the idea here is to say we are working with two groups. You have your groups of cookies, you have your groups of students. Obviously, we can see, okay, or rather we can just go to the method, the bus and stars method. So the bus and stars, it says, for you to be able to count the number of different combinations that can be there, is what you do is you take your stars, you add with your bus, and you're gonna choose your bus because you are given to the bus, hence we are choosing the bus. We are giving 5 cookies to the number of distinguishable items. That is our bar. But now they are saying your bus will be 1 less than the number you are given there. I don't know why. It's a method. I don't know. Maybe if someone knows why it's 1 less than, maybe they can explain it. Oh, I think they did mention that, okay, if we have A, B, C, D, you have 4 people. And so basically the bus is also your switch. As you are switching from one person to another, it's a bar. So if you have 4 people, how many bars can you have? So immediately when I switch to the next person, I must have a bar. So I give A, I switch from A, I go to B. It means when I switch to the next person and give the cookie to the next person, I must have a bar. Then if I give this one again and I switch to the next person, C, I must have a bar. When I switch to the next person, D, I have a bar. Obviously, I'm not going to give anyone people are finished. Not people are finished. But it's like we are done. We can't have a bar here because you are not switching to the next person. So you can see that always the bus will be 1 less than the number of your distinguishable items that are there. Hence, yeah, that ideology, because the bus is just a switch. Then your stars obviously will just be the number of similar items in distinguishable items. We can use this method to answer this question. So the bus and stars enable us to be able to count the number of combinations that can be made in such a problem. So I think in the textbook, they started with an example in how many ways can you distribute. Okay, let's use this one. In how many ways can we distribute 5 cookies to 4 students? How many different ways can we distribute 5 cookies to 4 students? So we must identify our star. We must also identify our bus, because the method of counting here is saying take your stars and bus and you choose your bus. That will give you the total number of different ways you can distribute those. So the stars is the number of indistinguishable items or similar items. So you can see students are different, obviously, but the cookies might be the same. I can take the cookies from the, just same packet. They are all cookies, so they're just the same. So the stars will be 5, the number of similar items. Then the bus, the number of distinguishable items. So again, the bus is the switch as we switch from one person to the other. That gives us the bar. So the bus will be 1 less than that because you have 4 students. Obviously, when we switch from A to B, from B to C, from C to D, you have 3 buses. So the bus is 3. So in how many different ways can we distribute 5 cookies to 4 students? Remember that also this combination also include the combination where some of the students, 4 students here, may not get that cookie. So it's also part, because someone can say, okay, I'm just going to give all of my 5 cookies to the first child, the rest of them won't get them. So that is a combination also. It's allowable that some of the students may not receive cookie, and that forms part of the combination in our total combination that we're going to count here. So we just say, okay, the stars plus the bars, choose the bars. So that is the number of different ways in which we can distribute these cookies, the number of different combination. So it'll be 5 plus 3, choose 3. Then this gives us 8, choose 3. Then we can just use the calculator to find and check how many different ways can we distribute 5 cookies to 4 students in anyhow. So whether you're just going to give the whole 5 cookies to the first child, that's part of the combination included in the 56. Whether you're just going to give um, 4 to A and give 1 to B, it's part of the combination included here. So you can see, like, it's like the bus and stars is a great method that really saves our time, because if we had to just list the different combination that can be there, it would take us a lot of time to reach to 56. So it's a really quick approach. I'm tired.
Wait,
Anyone,
using
please?
your stars and bars. Will they just specify, or we supposed to use stars and bars?
You can
The,
analyze the question. Yeah, Nico.
there may be a question whereby they say at least one student gets a cookie. You see those ones.
Yeah, and I've put some of them here so that we can just also just look at them. They can be in different ways, but I think the key thing, if they might bring it in a word problem, you check, okay, I have 2 different groups that I'm working with. Then in my mind, it might come, okay, if I'm doing counting, I have to think of the bars and stars method. Can I identify the stars, the number of similar items, indistinguishable items, the bars? Is this thing even being given to someone? Such kind of maybe connection. Because I saw also in the textbook, there were questions that were not clearly obvious that you had to use the bars and stars, such as new forming, how many 7 cell phone, what, telephone number can you form? And you can see from there, it's just not really clear that you have to think that the normal cell phone number, I mean, our choice, we have 2 groups. We have the digit from 0 to 10, and from those, we are going to be choosing and putting them in a space where 7 spaces where we want to form a 7-digit. So in that case, the 10, you see, I'm even failing to explain that, but it's like, you must see, you can just also check on the textbook the ways in which they can ask this. But so far as we have seen, he tried to bring them in, like counting the number of integers that are there. Like, you see, these are like different combinations, but let's just go through this and quickly just end this. Like in this question, again, it's not really clear, but you can just check on the textbook which questions would require you to use the bars and stars approach. Living. Okay. Okay, sure. Yeah, sure. So sorry about that. So yeah, we just want to look at some of the questions. Obviously, this was one of the questions that came in the TAT. Not in the TAT, in the quiz. And these are just some of them from the textbook. I think let's just start with these basic ones. How many integer solutions are there to the equation, this one? Such kind of question, we have to think of the bars and stars approach. because we can see that what's happening here is the question is asking how many different combination can you make of these integers from x1 plus x2 plus x3 plus x4 plus x5, such that when you add them, you're gonna get 13. So you can see we are working with two different groups. There's a group of integers that must be added, and like you are adding them, and they must give you 13. So in a way, what they're saying, one can argue, okay, we can have a combination to say, okay, I can just, x1 can just be 13 and all this can just be 0 because 0 is an integer. So this is the first combination in which we can do this. So when you use the bus and stars method, we are trying to find all those combinations that can be the same. Someone can argue this can be 12, this can be 1, and the rest can just be 0 and 0. 0 plus 0, this will still give us 13. Or someone can say, okay, this can be 2, 4, 2 plus 4. Our x3 can just be 0. That is 6 already. This can be like that. Then it gives us 13. So you can see we've shown quite, about 3 of them. And you can see that if we had to do that, it would take us a lot of time because, just imagine it would really take you a lot of time. And some of them you'd even forget to, or maybe I can use this because there are a lot of numbers to choose from 0 to 9. And how many integer solution can be combined in these ways to give us 13? So we have to use the bus and stars. So, but now they've given us a restriction here. Number 1, it says where xi must be greater or equals to 0 for each xi. So in this case, what they're saying is every xi must be greater or equals to 0. So this is the normal condition because all of them can just be greater or equals to 0 in a way. So we have to identify our stars. I think it's just gonna mute me and stop sharing. I'm just gonna be quickly back. Yeah, if the pen is stuck, it just mute me and stop sharing. Let me just quickly. Okay, so I think it's sharing, right?
Yes.
Yeah.
Yeah, so we want to use the bus and stars method to count those. So now we must identify our stars. Stars is the number of indistinguishable items or similar items in a way. You can see from these two groups, we can really agree that 13 is indistinguishable. Can't really, it's just a number on itself. It's similar. I don't know how to explain this, but it represents our stars. And those that will be taking some of the numbers from 13, just like us giving 4 cookies to people. So those are the number of distinguishable items, different items. So it will represent a bar. But our bar now will be a shift from us giving one person to the next. So in this case, it would be a matter of a number between 0 and 13 giving this integer value, such that when we add them, they must be equals to 13. So the shift between one integer to the next will represent our bar. So as we shift from x1 to x2 like that, or someone can just simply count 1, 2, 3, 4, 5, then the bus is just 1 less than that, which is 4. Then this is just the normal restriction, xi must be greater or equals to 0. Then we just, it's just, they didn't say at least one of them must be 1. So all of them can just start at 0 like that. So they didn't give us a restriction that no, this number must start at 1. So this is just the normal condition in which we are counting this. And we can use the bus and stars. Says stars plus bus, choose your bus. It's just, it's gonna stop sharing. It's just, ish. Yeah, but that's the idea. Yeah, so that's the ideology there. Then it will just give us, okay, for the first one, we are answering number 1 to be 17. Is that 17? Yeah, 17, 13 plus 4, 17, choose 4, and we can get the answer for that, which is 2,380. Just imagine if we had to be given this integer value, any number between 0 to 13, such that when we add them is 13. You had to, I mean, it's really a lot. You had to put down, 2,380 combinations, and I mean, it's really too much. It would take time. So counting really simplifies this and this approach that they discovered. So number 2, it says where xi is greater than 0 for each xi. So because these are integer value, if we're saying where xi is greater than 0, it means we have a starting point. We are not starting at 0 because they say greater than 0, integer value greater than 0, it will start at 1. So in this case, what they're saying, where each of these at least start at 1, as Nico was saying there, words. So here in maths, they're saying in symbols, rather, at least each of them must have a 1. So we are not saying all these numbers should be should at least some of them have 0. It's allowable, as like in the first case, the normal case. But here they're saying it must be greater than 0. Each of these terms must be greater than 0. So it means, obviously, because we're working with integers greater than 0, it means at least all of them must have a 1, 1, 1, 1, 1 as a starting value. No, nothing is allowed to be equals to 0 there. So now in that case, if we give each of these 1, 1, 1, 1, 1, we can go and ask ourselves to say, out of the 13 stars that we have, and we giving each 1 and 1 and 1, how many stars will be left? So it will be 13 minus, so the number of stars will decrease because we are at least starting each of them as every 1, 1, 1, because we are saying greater than 0, and the number that comes after that is 1. So at least all of them must start from 1 in a way. So this is similar to say xi greater equals to 1 in a way, because we are saying it's greater than 1 or equals to 1. So at least all of them must start from 1. So now we go and ask ourselves, because we have 13 bars, each of these must at least have a 1. Then we are going to check, okay, I only have 13 stars, and you are saying I must at least make sure that all these integers have a 1. How many stars will be left now if I give all of them 1, 1, 1? So you can see it will be 5. So we cannot subtract 5, because when you take them to that side, they're going to be 5. In a way, they're saying x1 must have a 1 like this, x2 must be at least 1 there, x3 like that. And if you go and solve for your new x1 plus x2, x3 plus x4 plus x5, it's just going to decrease to 13 minus those ones that you added there, minus 5. And you can see the stars will decrease to 8. The bus is just us switching from one integer value to the next. So obviously when I switch there, so I can just simply, the bus remains the same. They are unaffected because it's just a switch from giving this integer value, this one, x1, x2. So it still remains 4. So to answer that question, we can see counting using stars and buses. You take your stars, you add with your bus, and you choose your bus. So this would be 12, choose 4 as the final answer. And we expect this answer to be less than 2,380 because we have decreased the bus there, and we started putting, I mean, not the bus, the stars, and we started putting some restrictions. So remember when they say xi greater equals to 0, they are allowing some of them to be 0. So this is just the normal situation. But now when we say xi must be greater than 0, because we are working with integers, it means greater than 0 is started to 1. So at least each of them must have a 1, 1, 1. Then we just go and do the thing there and just solve and like that. So we can see also the number, if they are starting with 1, they will decrease because we've at least decreased the thing there. We have cut off those ones that will be having the 0, 0, 0, 0, and all that. So we are left with those that at least each value will start at 1 as we are adding them. So we'll have a 495 combination. And it gets worse as we go to number 3. I think we can just try this. Someone can just try to do that for us, where xi is greater or equals to 2.
It gives me an error.
What gives you an error?
Question 3.
I think your network, I don't know if it's on my side or is it on my side?
It's from her side.
I think your network there is refusing.
Kere, kara quiz no question, yeah. Like more like by representing that thing x1, x2, x3. So when they by represent as C, like what choose CSC, like it's the same thing. Like Halasanja 17 choose 4, not 13 and 5.
Yeah, it's the
It was
thing.
there in the quiz.
Which way? I don't think it's this one, right? It's not actually. Was it this one?
Yeah,
I think you are talking about. I heard it somewhere here. The one that was in the quiz is this one, isn't it? This one. I think it was this one. You're referring to which one? But we'll go to it. We can just complete this one and just move quickly because there are quite a number of different ways in which restriction can be given. And I think number 3 it's a bit complex because now let's just do it and see if it's complex. Let's hope it's not using pi. But there we just said it's 12 choose 4. 8 plus 4, 12 choose 4. Let's try number 3. It's saying xi must be greater or equals to 2. So at least all of these things must have a 2. Oh no, it's not advanced. I think we can just solve this.
Can I
Can you,
give
yeah,
you an answer?
please. Yes, please.
I have 35. Or should I?
Yeah,
The
can you
answer-
just explain?
So the question says, I can't see xi is greater than or equal to 2 for each xi. So meaning or every x in there must have at least two cookies
Yeah.
or 2 stars, must have at least 2 stars.
Two
So
stars, yeah.
so we're gonna, from the 13 that we had, we're gonna subtract two yeah x1 to yeah that, which is like 2, 4, 6, 8, 10. So it's gonna be 13 stars minus 10 stars, which is equal to 3 stars. So the total is gonna be a 3 stars plus 4 bars choose 4 bars, which is 7 choose 4, which is 35.
And this 7 choose 4, and it gives us 35. And you can see it decreases. You see the number of combination we can have it. The more we give restriction, and then when we give restriction, we're excluding those other ones. Can be 0, can be 1. So we are removing them. We're saying, no, at least these numbers, as we are adding them, let's start using numbers that are greater than 2. In a way, it's saying if you have your xi, it must start from 2. We don't want anything less than 2 as much as you are adding them, and we want them to give us this combination that will give us 13, 5, 6, 7, 8, 9, 10. My combination is failing me, but we can someone just give us that combination that start from at least 2? I'm even failing to get one of them, so how would I even get 35? 2, 4, 6, 8. Then we can just make the last one to be 13 minus 8, 5. So you can have your xi to be 2, x2 to be 2, to be 2, x3 to be 2, like that, x3, x4, x5. And you can see we can make different combination. What if I start with, I give this 4, you can see, then if you count them, how many combinations can be there? And if you list them with this approach, we're gonna get 35. Can we prove it? It's a method. We just need to believe. It's a counting approach. What do you guys think? Can we prove this, that the bus and stars is true? I think someone can ask, who proved it that it's true, really? Did they list all of this and check that indeed they will give us 35? Or we are just learning, we are just believing whatever that is being presented, so long as it gives us the correct answer beyond the book. But we don't care. Is there anyone who cares whether it works or not? We don't care. We want to pass. So, okay, we got the answer in the book. We move.
All in the war.
Yeah.
And sometimes they can even say, and look at the integers from negative infinity to positive infinity. Sometimes they can say x should be greater than negative 4. You see there on the stars and bars, the one that involves the things, the one that you're discussing on the group.
Yeah, I saw that they said -3 on the textbook. Ne?
Yes.
Is it -4 or negative? I saw the one for -3.
Yeah,
so if it's
-3,
-3, rather than decreasing the stars, it's gonna increase the stars, because you're going to say, okay, xy must be -3, like that, x2 -3, x4 -3, like that. If they're saying xi must be greater or equals to -3, they're saying at least all this must be -3, -3. So instead of if we had 13 bars, instead of it decreasing as we are used to here, the negative, when you take it to the other side, it will just be adding. So you just gonna increase your stars. And you can just try it out and check the answer behind the book whether it will correspond. But I think the ideology they would just, okay, must be -3, so we're -3. Then we take them to the other side. We'll say, oh, the negative, if we transpose, it's gonna be positive. The stars will increase in case if we are given such a restriction.
So the stars will increase by 3 for the x1, by 3 for the x2, and by 3 for the x3.
Then we just count, okay, how many number of distinguishable items we have. We have 5 people, then it should be 5 times 3. Then you just add it to the thing there. Or rather, you can just solve from the thing minusing 3, then you already solve for the final thing without this -3. You'll see the negativity they will add in case if the restriction is this one. It's not positive. We are subtracting from the stars because here the restriction is it's positive. It must be 2. So when you take 2 to the other side to -2 on your stars, decreasing them. But if it's negative, you'll just add instead. Can we do this one? Someone can quickly explain for us how they can approach this one. I took it from the textbook also, not this one. We don't want to do this one. This one. How many integer solution x1 plus x2 plus x3 plus x2 equals 25 are there for which x1 must be greater than 1? So they didn't give us the general, like for all of them, but they give us for specific. So we can also just go and work it out. And Maponya, can you quickly take us through it? And we can just pass it quickly and just conclude, because it's important that if we did this, we just end with the advanced counting using pi, where we are still working with bars and stars, but this is quite different. We have to use the pi method. Maponya, I think you can quickly take us through that one, and we can just.
These were given that x1 is greater than 1, so it's more like the same procedure that you just did on the other ones to say. Now in this case, since our stars are 25, in this case, if they say x1 is greater than 1, then we'll subtract 1 from 25. And if they say x2 is greater than 2, then you'll subtract 2 from, you just keep on subtracting. And then now you'll subtract 2, and then you'll subtract 3, and then you'll subtract 4. And then the number of bars haven't changed. You'll have what?
It's 3 bars.
It will give us 19. The bars will now be 19.
Okay. 19, 20, it's giving us 15.
Oh no, man. I forgot to subtract 4.
Oh.
Yeah, it gives us 15. Then now our stars are 15, and the number of the bars haven't changed to 3 bars. Then from there, the rest is history. 15 plus 3, and then
the rest is history. Yeah.
Then we'll have 18 choose 3.
Is it me or it's quiet?
It's quiet.
Eish.
Dibu, you are muted.
Oops, I was busy talking, sorry. Thanks. But yeah, I was just also emphasizing the point of, okay, Maponya use a very quick approach and just go and subtract quickly because he knows that, okay, this is the same x1 as 1, x2 as 2, x3 as 3, x4 is given, at least let it start from 4. So we're giving it 4. So we're now saying from 25, if we're given these things 1, 2, 3, 4, how much that would be left with, and just go and subtract as Maponya did, and we just get our stars 15. We can create a new interval like that. Okay, like this, we can just simply go and solve as normal. Then we just count 15, choose, there are 3 bars, because we're distributing 4 items, 3 bars, 15 plus 3, 18, choose 3. And I think that's just how Maponya did it as well. And just quickly go and subtract and get the answer. I was saying maybe someone could quickly try for us this, and I think we really need to be careful with this one. It was on the test. I think it's easy to get it right or wrong, especially in a multiple choice, because he brought answers that were very close. But the keywords gives us the restriction. Someone can just quickly try this for us. It was just from the quiz. Because we are really beyond time. Eh? We are really beyond time. I don't know, but we are beyond time. But we just want to quickly finish off with the pie so that maybe tomorrow we can just, it's Thursday, I think if we can just start early so that people can just have time to be also focusing on other topics they need to master. And so we are really beyond time. Okay, let's just quickly do it and just pass quickly to the advanced counting using pi, and why is it important that we have to use pi in this question beyond stars and bars. That's what they say. We have to use pi. So it's another method. Okay, this is just gonna mute me again because it stopped. Okay. Okay, I think yes, let's just do this and quickly move to that and just close off. They're saying A, B, C, D, E are 5 natural numbers given a restriction. Very important statement. Natural number. Sometimes if they say whole number, the answer would be different. Yeah. Find the number of ordered sets A, B, C, D, E possible such that when you add this integer value, natural numbers, you'll get 64. We are given a restriction in words and not as clear as we were initially given in these statements. So this is in words, they are saying A, B, C, D, E are natural numbers. And we know that natural numbers must at least start from 1. Although some natural numbers, they argue they start from 0, but the real thing. Natural numbers start from 1, 0 is not a natural number. So that's the restriction given in words. I think it's just important to note that there is a restriction, but in words, that these values must at least start from 1. Once we know that, we can go and answer the question. If we answer it blindly, assuming n greater than 0, we can get a different answer, because we are rather saying we are including whole numbers. And they didn't say whole numbers, they say natural numbers. So the restriction is hidden in words n greater or equals to 1, because natural numbers start from 1. So this means, obviously, if we know that everyone can know how to count those, they know that, okay, all of these must at least start from 1. So the number of stars will be 64 minus, if we're giving 1 to all of this, we are saying from my 64, I've already used 1, 2, 3, 4, 5 of my stars, then I'll be remaining 59 stars. Then the bus, as Maponya also emphasized, does not change, they remain the same, because the number of distinguishable items, they are the 1, 2, 3, 4. So there are 5 of the atoms. We can just say 1 less than that is the bar, which is 4. Then we can go and say, okay, it means the total number of 5 natural numbers, A, B, C, D, E, total number of combinations that can be made, 59 plus 4, choose 4. So give us 70, 59 plus 4, 63. Is it 63? Choose 4.